Good afternoon. Well, the project of the defibrillator and the pacemaker starts with a program created in LabVIEW. So this is the block diagram of the program that I say. So for simulating the signals of the tachycardia, bradycardia, and the normal signal, it's necessary to create a simulation arbitrary signal, as you can see here and here and here. So how it works? So we can define a type of signal between x values and y values. So in 10 milliseconds, I'm going to take a point of 1 millivolts, and that's how we create all the signal that you can see over here. So with the values that we can find in articles and different things that you can access on the internet, you can create your own signal of tachycardia, bradycardia, and what is the name? Fibrillation auricular fibrillation, ventricular fibrillation. So about the normal signal, we have that it has a frequency of 72 RPMs per minute, and the tachycardia has 120 RPMs, and the bradycardia has 60 RPMs. So how it works? In the normal signal, it doesn't have any sense, so it's just the sign and it multiplies by a factor of 250 to show in the waveform. It doesn't have so much complication. For the tachycardia, we have a peak detector. So when the peak detector detects an R peak, they're going to send a pulse on the pin number 4 of our Arduino, of our device, and it's going to see on the oscilloscope. The bradycardia has the same logic, a peak detector and the pulse. Finally, for the fibrillation, we have also a peak detector to give an impulse to the circuit that you can see over there to make the circuit start to work and the relay change the position.
Well, the relay or switch change the position and get when their both races get energy, and the relay change the position. Well, the defibrillator use the logic in the diagram in the little diagram is the resistance of impedance charge the capacitor, and switch or relay change the position and discharge in the person or patient, and the inductor conserve the current. Well, in this moment, I have the both races of condenser and relay, and inductors. This system proprietary of is a model of the one system real, and in this moment, you this how would you to use.
So as you can see over here, we have a graph that shows us the signals that we created previously on the block diagram. So this is the normal signal. So it can start the pacemaker or the defibrillator because it's a normal signal. As I say, it has a 72 RPMs frequency. When we change to tachycard, we can see a way too much accelerate because it has 120 RPMs as frequency. In the oscilloscope, we can see that when the program detects a R peak, it's going to show us a pulse or a square wave in the same time of the on a duration of about like 25 milliseconds. And the fourth bradycar is also the same, as you can see over here. The signal is slow, and as I said before, it has a frequency of 60 RPMs. And in the oscilloscope, we can see a pulse, each with the peak detector. When the peak detector detects a R peak, it sends a square wave on the oscilloscope. And finally, for ventricular fibrillation, so we have this signal that we create. The fibrillation doesn't have a particular form. It's just like noise. So we create this kind of wave, and in the oscilloscope we can see that when the voltage is the max voltage, we can say like a shot, like an activation of the relay, and we can see a pulse with a form of the charge of the capacitor. About the frequency, we can say that in the tachycard we have a frequency of 145 RPMs per second or per minute, and in the oscilloscope we can see that the pacemaker make his shot or his discharge with a frequency of